Hello everyone, I'm gonna show you the fastest way to set up a linear workflow within Autodesk Maya with the recent versions when they introduced the color managing system. So I got this scene which is set up with just a few primitives with the Lambert shader on, a render cam, and also the only light source in this scene is an area light with the decay rate set to quadratic. You will always want to set this to quadratic unless of course you're simulating daylight, in which case you should use no decay, since that's how the sun works. And if you're going to simulate sunlight, what you can do is use a physical sun and sky system, which is already in Maya. And I'm gonna touch upon that later. So there's nothing fancy going on in the scene at all, and the light itself there's a ray trace shadow applied to it, so we can see the shadows, and that's basically what's going on. So what's gonna happen when I render this image? You're gonna see that it appears very dark. And for anyone that's never used linear workflow before, you're gonna think that, well, nothing is wrong. That's how it's supposed to look. In order for you to light the scene well and to make everything over here actually be visible, what any person probably would do is go out to the light source and increase the intensity to, let's say, 30. Well, what's going to happen is when you render this image is that sooner or later you're going to wash out and overexpose certain areas that are close to the light source itself. And this is a huge problem. And if you think that, okay, I can't use that amount of light intensity, what you might do is duplicate lights and put all kinds of light sources in the scene, which might be a bad thing down the road, depending on the project you're doing. So instead of doing any of that, what we need to do, well, we can let that be at 30. What you need to do in the render view is right-click, go to Display, and make sure that this is set to 32-bit floating point images. That's going to enable the render view to display the high-quality images. If you have it on the standard 8-bit, however, it's going to look really ugly. So go to Display, Color Management, and over here we can see Image Color Profile and Display Color Profile. Maya always works in a linear format. It's doing all the math correctly and all that. So what these two settings does is telling Maya that the image color profile, what we're putting into the render view, is actually linear, but we want to display this as an sRGB image, meaning that it's friendly to the human eyes, that we can actually see what's going on. So when we tell Maya that we're working linearly, look what happens. There's all this kind of information over here in the image that you thought wasn't there to begin with when it's set to the standard setting. And what's happening is that it's not re-rendering the image in any way. It's only applying a color profile to the render view, meaning that you're telling Maya that the scene is linear because it is linear, but you want to display this as an sRGB image. So with that said, what we should do naturally is go into the light again, and now we can turn this down. Now let's put it at 20 or something. And if we re-render this, you can see that with only one light source in the scene, we can still light up a much bigger, we can actually see a much bigger area. What this is going to do is it's going to help you to avoid these kind of hotspots that are appearing here at the bottom. So if I re-render this at 15, you can see that the problem is almost completely gone. And remember, this is just a test scene that I've thrown together. So this is, I mean, depending on how you put your lights and all that, that's gonna become a factor as well. Okay, so what we've done so far is telling Maya that the scene is linear, which it is by default, and we want to display it as an sRGB image just to see what is going on. So what about textures then? Textures, 99% of all those textures that you use in a project are going to be JPEG images. And what JPEG images are, they are actually images that has a color profile embedded into them in order for us to actually see them as we expect to see them on the screen. If a JPEG image was linear, displayed in linear, it would appear way too dark, just like I just showed you, like this. This is how a JPEG would appear to your eyes on the screen if this RGB profile wasn't attached to it, which it is by default. You can't change that. And that is what we call a gamma corrected image. And that's because a JPEG image is always an 8-bit image, whereas HDR images, for example, which you use for final gather rendering or such similar things for reflections in your scene, those are always, or at least should always be, 32-bit float images. So they don't have an sRGB profile attached to them, and therefore they aren't affected by this kind of workflow. So if I were to put out, let's apply, I've prepared 2 different materials for this example. And if I apply this material with a wood texture on it, I've forced this to ignore all the settings that we're about to do and always keep this as a color corrected texture. On this, however, I'm gonna put another shader which it's going to be affected depending on the settings we're about to make. So if we open up the Mental Rig global tabs and go to Common, we can see that there's Enable Color Management. And what that does, if we enable it, it's going to say, in this case, that every texture that we put into Maya that is used on a shader in the scene is going to be an sRGB image. For example, a JPEG image that we use for textures. And we want in the rendering process that Maya outputs these files as a linear texture instead. So there's a conversion going on in the render. So what happens if I were to render this instead with textures on? And as you can see, because we set the color management with these settings, this appears much darker than the other one, because this texture, the settings of how it appears is being decided over here. This one I have forced to not care about these rules that I set here, but I've set it to appear as this would if these settings were in fact not applied. And to do that, I'm just going to show you real quick. If you go to this material and go to the diffuse color, you can see that the color profile of this diffuse texture is set to use default input profile, meaning that it's going to obey whatever rules you set over here. On this, however, if you go into the diffuse texture, I've set the color profile to display as linear. And that is exactly how this one would appear if we turn this off. So if we turn it off and go in again, save the image, these two look the same. And that's the basic principle of it. What that setting is doing is it's color managing it, making this linear because we want to work in a linear space. The scene itself is already linear, but we need to tell the textures to become linear as well. What is happening in this example when I've turned color management off completely for the textures is that the render view, because of these settings we made earlier, is displaying an sRGB output. But also in this case, the texture without color management has an sRGB profile embedded into it, meaning that what we're seeing here is, well, in fact, it is a double gamma correction. It's gamma corrected from the start, and it's also gamma corrected in the render view. And when you gamma correct it, this is how this render should look. So that is all there is. It's not complicated at all. Just to go back and show you a real quick summary of what we've been doing is enabling color management with the default setting sRGB and linear sRGB. Right click, making sure that this is set to 32-bit float point. Go to color management and setting this to be linear. And that is all you have to do in regards to setting up a linear workflow. In addition to this, I want to talk quickly about when you're saving this out, when you're batch rendering this out, it's going to appear like this in the images. If we were to render this out as an Maya IFF file, it would appear like this. And you would notice that as soon as you try to come in post-production and try to, let's say you would want to make this brighter, the image would be really ugly. There will be speckles all over the place and artifacts and all that kind of stuff. And that is because the image itself isn't high quality enough to be post-produced very heavily. And fixing this, we go to quality, go down to frame buffer, and go to data type. The data type by default is set to RGBA 8-bit. And that doesn't allow a lot of post-production to be done after you've rendered this out. If you would like to pretty much relight this whole picture, there isn't enough information over here to be doing that in an 8-bit environment. What you would need to do is go down to RGBA half 16-bit at least. And that is going to store more information about the color and brightness per pixel in the image. And if you want absolute full control of this and enabling you to post-produce this pretty much however you want with color correction and brightness, use RGBA float 32-bit images. And in regards to 32-bit images, the file formats is quite interesting. A lot of people use Maya IFF or TIFF or whatever. I've quite recently started using OpenEXR exclusively. I only use that nowadays. And OpenEXR, what that is a file format which contains, let's say you would render a project with 10 different passes applied to them. What this file format is doing is packing all those passes inside one single file per frame instead of creating, if I were to go into my my images folder, if I use a Maya IFF format and render 10 passes out, what I would get essentially is 10 different folders with all those passes. But with the OpenEXR, what's happening is all those passes are being packed into one single file per frame. So when you go into Photoshop or After Effects or Nuke or whatever you're using, you can break those passes free and handle them as separate images instead. And it's a great way to post-produce your images, so you have everything stored in one place instead. But note that using 32-bit images, first off, but also OpenEXR is going to increase your file size. But it's all worth it if you think about it. And also I want to add in regards to OpenEXR, some passes requires you to use 32-bit images, so you might as well just get used to using 32-bit. Let's say we were to add a motion vector pass for this specific render that we supposedly would do. It shows up like My 2D Toxic, that's the name of it. And if you click it, you can see over here that the frame buffer type is locked at 32-bit float, meaning that this pass itself cannot be rendered in an 8-bit or 16-bit environment at all. You need to use a 32-bit float. So if you don't want to use 32-bit because of saving space on your hard drive or not using EXR, you're gonna have to go back and render that specific pass separately anyway, ending up with different folders and stuff like that. So, like I said, you might as well just get used to using 32-bit OpenEXR renders. Another thing that people are asking is, how do I do if I want to use the physical sun and sky in this? And I'm going to show you real quick what to do with the sun and sky system if you use this linear workflow method. What happens is when I press physical sun and sky, it applies it puts a directional light in my scene that's it's simulating the sun, which is an awesome way to do outdoor renders with. It's really cool. If you haven't checked it out, do so. What this is going to do, it's going to, in my camera, if I go down to mental ray, you can see that it added environment shader, physical sky, and also a lens shader. We're going to take a look at what happens when I render this by default, if I just enable physical sun and sky and I render this image. And you can see also that automatically Final Gather is enabled by doing this. And you can see that the image itself is really washed out. It's just way too bright, and it looks horrible. The reason for this is that in the lens shader, the exposure simple shader, or node I should say, what happens is that it's by default it's set to gamma 2.2. To counter this problem, set this down to 1 instead. And so if we re-render this image, you can see that sure, things are quite bright still, but remember that I haven't deleted my area light yet. It's still in the scene, so that's casting a lot of illumination as well. So compare this one, how washed out and extremely ugly this is. It just looks horrible compared to this when I set the gamma to 1.0. Really cool. And also if I want to delete the physical sun and sky, just press delete. And also something that people are wondering about as well is, what if I use an Idl Sphere for my render when doing linear workflow? You know, the dome that comes up to cast not sun, but light in general and reflections in your scene. What happens is if I enable this, and I'm just going to import the typical kitchen probe, the most standardized HDR image there is. And I'm going to set this to angular because it's an angular image. And if I were to render this so you can see from a perspective view what's happening with the background, you can see the image in the background because in render stats, primary visibility is still turned on. And what happens if I go into common and disable all the color management for all the textures? What's going to happen? Well, absolutely nothing, simply because this color management only applies to images that have color profiles embedded into them. whereas 32-bit images like kitchenprobe.hdr are float 32-bit images, so they are not affected at all by this. So that is basically everything you need to know about linear workflow in Maya in the recent versions. If you got an earlier version, you might have to go through the enormous pain of hooking up gamma correction nodes to all your diffuse textures and all like that, and still use, I don't know, whatever method you would prefer to use, but you could use a lens shader and all that. And if you can use a version of Maya that has the color correction, please use this method. It's easy as hell to set up, and your renders are going to be way more physically accurate, and you're gonna work correctly from the start instead of adding tons of lights in your scene, or duplicating the lights for that matter, and making the scene become really awkward to work with. So that's basically it. If you have anything to say in regards to this tutorial, if you think I missed something, if there's something you would add, or just say hello, please do so either on YouTube or my blog, cambranddesigns.com/blog. Thank you, and I will see you again.